Hello and welcome to the Supercharged live stream. I'm Paul.
And I'm Surma.
Surma, tell me, what is better than 2 dimensions?
4.
Let's make a 3D card flip.
7, 6.
Hey, awesome. Right, so
Let's get started.
yes, 3D. Everybody loves 3D, and there's loads of people I already see in there on the chat.
We got people from Austria, Costa Rica, Netherlands, everyone. Hey, welcome.
Thanks
I'm
for
going to be
joining.
monitoring the chat, so keep talking. I'm just going to try to keep up, and if you have any questions, post them there. I'll weave them into the live stream and see if we can, if you can change where this is going, maybe.
All right, so I'm going to dive right into some code because that's how we want to roll today. Everybody's busy. Right, a bit of HTML. Let's see what we'll do is we'll drop in a title which we shall call the card flip. Let's call it 3D card flip, whatever. 3D card flip. All right, let's get some styles in there. So we need the link rel equals style sheet. href.
You have to fix the indentation on the title.
I know. I was gonna.
Okay, good. Because I can't.
No, you're struggling. There you go. Look, it fixed it for you.
It's so much better already.
Styles.css, fine, just going to go with that today. All right, styles.css. CSS, there we go.
So in the announcement, people have already said, or at least there was one comment saying that if a 3D card flip is not material design,
No.
and that is correct.
It is.
It is not because we just do what
We do,
whatever.
we do what we think people want to see and what we want to make. And in this case, we thought people would want to see some 3D card flipping stuff, and there is going to be some, I think, really interesting bits and pieces in today, because when you're talking about 3D, you actually have to do a little bit of figuring stuff out.
What's it going to be? Are we going to use CSS transforms or OpenGL?
Hey, my watch just. Hey, I've reached my goal for today. You'll be thrilled to hear. My watch tells me how active I've been. I've just hit 100% because there's nothing like.
You did some excessive typing just now.
I did do a lot of excessive typing. Obviously, it just decided. You know what?
If you want to stay fit, type more.
Live coding on YouTube is one way to stress your heart. So I do that apparently. Anyway, right. Let's make let's see, SC card. We'll just go with SC card today. Why not?
We also have the question: is this real life? Yes, it is.
It is very. Well, as in, are we doing this for real live? Yes, we are. Yeah.
It is really live. Like, as I said, keep posting questions, ask them in the chat or on Twitter, and we can answer them for you live. This is how it works.
Yeah. All
right, let's dive into some actual code here.
Yeah. I'm doing that. I've already got. So I've got a custom element. I'm going to do it today. I'm going to call it SC card. And let's see, we'll put a div here, which we're going to say class equals front. Let's do that. Because we're going to have a front of the card and we're going to have the back of a card. So we'll put, say, supercharged on the front of this card. Div, and then we'll do another div inside it. And then you don't have to do it this way. There's loads of ways to do it. We'll just do class equals back. And I have sort of thought ahead a little bit here.
How dare you?
I know, and we actually I made this little thing for the back of the card, a little supercharged graphic there for us to
I
pop
wish
on
my
the back
hair
of the
would
card.
look that good in real life.
I know. I wish I had hair, so it's fair.
We have
really.
something in common, I guess.
Would change hair if possible. There you are. Right. So front of card, back of card. And what I'm going to do is just going to temporarily just pop a button on here, and we'll say flip card. So that's fine. It's not going to look great, but we'll just put it there for now. Right, so we've actually got some markup. Let's go ahead and
So I guess
drop some.
in case someone doesn't really know what a 3D card flip is, and you're just starting with front and back, what we're doing is we're going to have a card like you might actually know from material design, and I guess this is why people thought of material design when they announced this. And we're going to flip it over in 3D.
Yeah, so it's going to come out of the screen, going to flip over, and then drop back onto the screen. And we're going to have to do some work with like faking shadows and stuff as well for it to look right. But we can start by having the front of the card and the back of the card, and then we'll work our way.
Hence the two class names.
We will work our way from there. So we're going to have to do a little bit of styling to get this underway, though. Body, let's say width 100%, height 100%. In fact, I'm going to have to do that in the HTML as well. Whatever's. Right, do that. And then I'm going to say that the HTML is going to be display flex today, and it's going to be, it doesn't actually matter, we can do
Flexbox hotness.
Align item center, and then justify content center. I think that does it. we'll do SC card, and I'm going to go, because I've already got this image, so I'm going to make my card, what is this? It's 260 by 380, so I'm going to say my card today is width 260. For what it's worth, I have done this kind of approach before, and you can make the cards responsive. So I am hard coding these values today, but this technique works even dynamically. It does get more involved, but the concepts are the same.
I guess this also makes obvious that this is not production ready code. It is claim that we're probably going to repeat in all future episodes as well.
Yeah.
This is more about the techniques on how you achieve certain effects without dropping down to 2 frames per second, because you can easily shoot yourself in the foot if you use CSS the wrong way. But if you want to do something like this on your production website, you should probably tidy up the code and maybe even, do some testing in other browsers as well, which we are not going to do today.
Correct. So what we're going to do is there's one of the first things that we're going to see here. Height 100%. Right, so we've got the front and the back. So what I've said is the containing element, the card, position relative, set its width and height. Then the actual front and back, I've said back face visibility to hidden, because as we flip the parts, the front and the back of the card over, we want that to, we want the contents to disappear as it's flipped, okay? And by default, I don't think back face visibility is set to anything other than visible. So we want it to be back face visibility
What
hidden.
we would see otherwise, I think, and correct me here if I'm wrong, is that one of the cards is always rendered first, independent of where they are. So it means we would just see the top half of the card, but rendered backwards.
Yeah, exactly.
Which is not what we want. So that's why we set it to hidden.
Right, so we have that, and we need to do a little bit of, right, so let's say background. We'll have a look at what it's actually looking like in a second. Let's do that. In fact, let's make it a little bit darker there. And then we'll say, so we're going to say the front of the card, I'm going to say the front of the card is background. What do we got? Let's do it 444, color. And I'm also going to set the contents of the card to be central, like so. Right, let's see what that looks like. Okay, so actually we are in a reasonable spot here.
Why is it so tiny?
That's a good question. I think it's because of the way that this screen is set up so that they can do the live streamy stuff.
16 by 9.
I obviously know loads about live streamy stuff.
As we have seen in the promo. You did turn on the camera successfully, but that's about it.
Felt good. Right, so what have we got here? We've got the front of the card and the back of the card. Let's do the back of the card as well while we're here. Back of the card.
Interesting question on the side. Where do you think what you're about to write, the flipping card, is a reasonable or even a good choice in terms of UX? I think
go on.
I think intuitively it's a very good choice for anything where you have details that you want to hide and that the user wants to look into. So you have like a topic which just has the big topic name on it, and when you click on it, it flips over. Yeah. Just like with like an actual flip card when you do like flashcards, I think you call them, when you try to learn words when you learn a language.
So here's what we've got here. We've got the front of the card, and the back of the card is just appearing over the top, right?
Yeah.
So what we can start by doing now is we can actually say transform, rotate, and I'm going to go with the y-axis. So we're going to flip around the line down the middle. So the card's going to come forward, flip around its vertical axis, and then go back. We could do it over the x-axis as well. That would also work. So, and we can see how we get on, whether we want to actually pursue that one today. Now, with the back face of the card hidden, it's still there, but we won't see it. So we're doing really well. Let's add on, let me see. Tell you what we'll do is we'll make that an H1 as well, like so. And let's just change the font family because it's currently not very nice. Let's see what we've got for Arial, that'll do it. And that's still quite monstrously large. So yeah, that'll probably do it. For now, but let's just change Okay, just gonna hack this in today. Font size 24 pixels, just a bit on the large side. This flip card, I'm gonna fix this now as well while we're here. What I want buttons on the front and the back for flipping the cards, just so that there's a button that covers the whole thing. Loads of ways you could do this, front and back. And while we're here, let's put on a border radius of 3 pixels. Again, just so that we're seeing a little bit of roundedness on the corner, just so it feels more like a card. So the front and the back, and I want to say that that applies to the button, so I could just get rid of that. That would do it as well. La la la. There we are, the front and the back. How's everybody doing on the chat?
It is very much alive today, like lots of conversations going on.
Fabulous.
We just got a question. Did we consider using the animation API instead of CSS animations?
Who said we're doing CSS animations? Oh, smarty pants on the chat. You're absolutely right. We're going to be using web animations today. Haha, I was saving that. And you've just come storming in via Surma and... Yes,
and you know the worst part is he's going to blame me afterwards.
Oh yeah, I'm totally going to...
I'm going to take the...
Not even afterwards.
Right now.
It's his fault. There you go. Yeah, absolutely. We are going to go down that path. You can do it with keyframed animations. I actually found that when I've been doing stuff like this, the Web Animations API is brilliant for this. Its support is actually really not good by default. So you actually have to look at the polyfill if you want to use it. So for production, again, you might want to reconsider. And also custom elements as well. They're still very early days. So we're talking about the approach, but...
I think it is possible to do this with keyframed animations as well. But, we like the bleeding edge. We want to teach new things here. So... I want to go there.
Background none, border none, and text indent minus 10,000 pixels for now. Okay, so we actually have a button there on the front and the back. So this is good. Now we can actually get into some JavaScript and let's do a custom element. So we're going to do SC flip card, and I called it SC card. So SC card. And we'll see how we're going. I don't think we're going to have attributes today, so we'll leave those out. Okay, so let's think about this. So we've got front and back, so I know we're probably going to have to enumerate that at some point. So let's just do that now with a getter sides. Return front 1, back 2. So that's one thing. And we know when we create it that we're showing the front of the card. So we can say this side equals this dot sides. In fact, if I did static, there we are. I can do dot sides dot front. So we're saying the front side is the one that's showing at the moment. Right, now we need to query select the front and the back. So we've got front equals document dot query selector. There we are. Front. I'm having a bad typing day, and anybody who watches this show often will know that every day is a bad typing day for Paul. Front and back. Okay. So we've got the front and the back, and we need the buttons as well. Well, actually, what we're going to do is we're going to create a flip function, and the reason we're going to do that is because we want to be able to call it on the API. If we wanted to just grab the card from somewhere outside and say, just flip the card, we should be able to do that. And then the buttons inside, we'll just get them to...
That is the mindset of custom elements, right? That you expose the functions that are supposed to be in the API explicitly.
Yeah.
So on cards, our card is supposed to be flippable, so we give it a flip function.
Document.query selector all. Button for now, and then we will say you can do for each, can't you, on a node list now? Oh well, I'll do array dot from this dot button. Wow, buttons.
So interesting remark, I think. You did document query selector, but since you have all the sides of the card as shown, you could use this query selector and not traverse the entire document.
Oh, which is no, they're quite right. I fully intended to do that, and it was a brain problem moment for me there where I just didn't get it quite right. So thank you. Yep.
So for the people who just joined us, or maybe joined us just now, welcome. This is Supercharged. We are doing a 3D card flip. We're gonna have a card, and when you click it, it's gonna flip over, and you can see the backside. And that is actually pretty unusual on the web, which is why it's going to be interesting. And we're going to be using the Web Animations API. We're going to be using lots of CSS and JavaScripts and custom elements. Yay! So if you're interested in that, join us and watch Paul make mistakes.
Yay! It's fun. All right, so we're going to do... so what I've got here is I'm just kind of stepping through the buttons and just saying when you... when we click on a button, we want to call the flip code, which is going to be this here, So let me just drop a debugger statement in there so that when we click, we know that that's doing its job. We'll have to wait and see whether the other side does its job, but that for now is doing its job. So we actually have to figure out what it involves to do the flip. Do we have any attached and detached? Actually, do you know what? I should be doing that in here.
Probably.
Yeah, so these
are the kind of things that I never can quite remember if you can attach a event listener before you attach it to the DOM and then quit.
Well, it worked, but I think for cleanliness sake, you'd normally want to do this kind of sort of attaching and detaching is the point where you kind of put on the listeners and take them off, probably. So I mean, I'll put it there for now, and I should have a corresponding detached, but I'm going to leave it just for now in the interest of time. Right, so flipping the card. So we've got an animation that we need to do. So let's do this. Const side 1 equals, and this is the where the fun stuff is about to happen, because we have to first of all, right, put it this way. To do the 3D, we're going to actually have to put perspective on here. Now, anybody who's looked at this
has been confused by this.
Yeah, you measure perspective in pixels, which is this kind of virtual camera. Yeah.
Yeah.
How much time have you spent looking at this? Enough to be confused?
I think I understood, but I have not used it yet, so I might as well be wrong.
This is going to be fun. Okay, so we've got a perspective of 500 pixels. Basically, one way to remember this is the smaller the value, the more extreme the 3D motion is going to appear. As the perspective value gets bigger, you get sort of less distortion. And 500 pixels for something like this.
You get more isometric. It almost looks like
that almost more.
Is it distant?
Yeah, basically, it's to do with how much. When something's rotated and the size that it is, how much it's going to get shrunk or sort of stretched by.
So basically, if you have a small perspective value, you get this fisheye look, right?
Yeah, you just get more extreme 3D motion. And 500 pixels is typically 500 to 1,000 is normally a good place to start just for a lot of content. It's a place to start.
And this is where literally magic numbers come in. Nobody has yet explained to me why these numbers are good.
It's because it will be dependent on how far back you push the thing and how big the thing is that you're pushing as well in the Z space. So because of the kind of size of card it is, 500 pixels is probably going to be okay. Now, what we actually have to do is we're going to have to push the cards back in Z space, because what we're going to do is we're going to have them kind of come forward. Well, in order for them to come forward, they've got to be at the back first. So...
Also, if you lose track at any point, that is fine. The code is going to be on GitHub later on our UI element samples repository. We're going to link to it in the description. The video is going to be up as a video on demand on our YouTube channel as well. If you're not subscribed, you should be subscribed. So click the subscribe button below.
Cool. Right, so side 1, and I'm calling it side 1 because depending on which side is actually going to be the one that we flip, as in the one that is at the front at that particular moment, is the one that we actually have to work with. So we're just going to have side 1 and side 2, and we'll hot swap depending on which side is actually facing us. Anyway, so we're going to have a transform. Now, the transform is going to start at, we're going to say, we're going to translate whichever it is, translate Z. I'm going to start at minus 200 pixels. So I'm going to push it back in 200 pixels. And it's going to have a rotation of 0 degrees. Okay. So it's basically pushed back in Z, and it's got 0 degrees, so it's not rotated at all. The problem is right now, if I were to, in fact, let me just drop that transform on.
Just to explain this array a little bit, this is the beauty of the Web Animations API, because you're basically declaring an array of CSS values, and those get transitioned from one element to the next.
Yeah, we're definitely going to cover all that. Here's the thing. You see what happened there? When I actually just applied that translate Z value, that Z value, to the front, you can see that it got scaled down, right? So without it there, so now we actually have to scale it back up so that it doesn't look small, right? Because we don't want to be kind of coding it at 260 by 380 and then going, but actually it's only 185.71, blah, blah, blah. That's not going to work for us. What we actually want it to do is we want it to appear as it was originally. So do you know how you calculate, sir, the scale factor that you require? No. I wondered if you would, because
I could probably, I would claim that I would be able to work it out, but I can't do it in my head.
It's basically, it's in the spec. It's this one-liner that's actually in the spec.
Oh, really?
Yeah.
That I did not know.
Yeah, if you read through it, it will tell you. And
I thought we'd have to do the camera angle. And
it's the scale value that you require is it's the perspective. So in this case, it'll be 500 over. And then 500 minus whatever the distance, so it'll be minus 200, which is just plus 200, right? So 500 over that. That's how far it's been, that's how much it's been scaled down.
I will have to check that later.
So that's how much it's been scaled down. But so if we did that value, here, if we do that, it's 0.71, right? Is what it currently is. So in order to account for that, we actually have to do 1 over all that lot. So it has to be 1.4 scaled up. To kind of reverse it.
Which coincidentally is almost the square root of 2.
There you go. So we can do that instead. Would actually do it. Now I'm hard coding these values. Again, you wouldn't do it in for reals because you probably want to make this totally dynamic. But we can say, or we can transfer that across to a template string, and we can say scale, and then we'll do that. Okay, so this is our starting point. So it's going to be scaled back up, but it's actually pushed back at 200 pixels. Then what we want to do is we want to bring it forward to, say, minus 100 pixels. We don't want to bring it up to 0 because half of the card will disappear when we rotate it. We want to leave enough space for it to actually...
flipping is going on.
Yeah,
we want the entire card to flip. So that's why we are doing this whole dance where we're pushing back, but don't want the user to think that it's actually going backwards. Exactly.
So then we're going to flip at minus 100, we're going to flip it over 180 degrees. And then the last thing we need to do is we need to push it back down to 200, like so. So these are the kind of keyframes of our animation. Does that make sense? Is everybody happy so far on the live stream? Is everybody not terrified of that? I don't think they will be. They're a smart bunch. Right, so...
Looks good so far?
Yeah, cool.
Nope,
so that's the side one. Now side 2 is going to be the back of the card, and it is pretty much going to be the same thing, except at the moment it's already at 180 degrees because it's got its back to us, if you like. And so we need to rotate it around from there to 360 degrees. Basically back to 0, but we want it to go in the same direction, so we'll take it up from 180 to 360. This, hopefully, should sort us. Now what we can do is we can switch based on what the current side is. So case is that it's flipcard.sides.front. So if this is the front card, we're going to say this.front.animate, and we're going to give it the side 1, and we're going to have to make some timing data in a second. Whoops, a daisy. Same goes for the back. We want to use side 2 for that with the timing, and obviously it's complaining because timing doesn't exist yet. Also,
and let's create it.
Default, because it's probably going to want that. We can throw a new error.
Well, if that happens, something really did go wrong.
Unknown side is where I'm going.
It's like the good old days when you have enums and suddenly...
Yeah, something goes really, really, very strangely wrong. So we need to do the back. So when it's the back of the card, we're going to do side 2 there and side 1. Okay. So this, we just now need some timing information here. Oh, it doesn't like it because I'm throwing. There you go. So timing, const timing is, it's an object, and we're going to say duration, and we'll do it slowly at first. We'll do it for like 3,000, so that's 3 seconds. Iterations, we'll set that
look at it.
1. Easing, we need some of that, and we'll say ease in out so that we get a nice easing on it. And then we need a fill. And the reason we need a fill is at the end of this animation, we don't want it to snap back to the first frame. We want it to hold on the final frame. So we'll fill forwards, which is the correct keyword for that.
So this should look like, all of these keywords should look very familiar if you've ever done CSS animations.
Yep.
Which is exactly the point. So basically what the .animate call does is it takes an array of CSS property dictionaries and it will animate from one dictionary to the next one and to the next one until it has gone through the entire array. So you can basically define a sequence of movements and they will be executed as one animation very smoothly and
exactly.
fluidly.
And so what we're going to do is I'm just going to remove that transform that I put there. Okay, all being well, it goes up, flips, goes back.
Look at that.
We actually have now a card flip. Now I don't like the timing of it. Because if we just bring it down a little bit faster, or a little bit, yeah, So it's okay.
Most of the time is spent in lifting up and down, and the flip itself is very fast.
And also it feels laggy to get to the flip point. The interaction that you always want with these things is kind of do the thing that the user has actually kind of asked you to do as quickly as you can. So what we want to do is we want to front load this animation so that coming up forward is actually going to happen faster. Get into the flip and then come back down slower. So what we can do here is what we normally do. We do an offset inside the object, and you put in a value between 0 and 1. And so at 0.15, it's going to basically, normally if you don't put it, it'll be 0, 0.25, 0.5 and 0.75, or no, whatever. No, it wouldn't. It would be 0, 0, 3, 3, 6, 6, and then 1.
So you have whatever the entire duration is, the start is 0, the end is 1, and you can define the start points of all the sub-steps.
Yes, the sub-steps by putting in this offset value, which is a value between 0 and 1. So I'm going to do an offset of 0.15 for when it's coming forward. I'm going to set it to, say, offset 0.65 here for when we are at the flip point. So we spend half of our time, rather than a third of our time, we're going to spend half of our time flipping the card over. So hopefully just a touch slower. Let's see how that looks. Yeah. So that comes up quickly. You good?
Yeah, I'm just
chatting. Can't multitask, right?
How's
it going in there?
We got some questions and people sharing links, answering questions for me already, which is amazing. Thanks for everybody who's helping out.
Woo!
Looking good.
Yeah,
looking really good.
So what I've done is just by finish typing, then I can talk to you, dude.
Sorry,
you
I'm
good?
done now.
You good? You good? Okay, so what I've done is I've used the offset, and now it's actually it's a little bit sort of slower. So as they're kind of lifting up faster.
Other things in the array keep the same default offset. So the last one is still 0 points. Oh, you have to change that.
Yeah, I've changed these. So it's basically this is happening. The card's coming forward by 0.15. It's taking half of the available time, 0.5 if you like, to do the flip. So the flip feels slower, and then push back like we had it before from 0.65 to 1. So coming forward is 0.15, and it gets 0.35 to push back. So the slowdown at the end is more strongly felt than.
Okay. But if you hadn't passed in the 0.65, it would have still had the default value of.
It would have divided the available time, which would be 0.85 between these two frames, which you can play with these numbers and just try and get different feels. And that it's also affected by your easing as well, because it's going to try and kind of figure out that kind of stuff.
Question on the side: what do we use to build for ES6? We use nothing.
We currently do not.
We use everything that is available in the current Chrome stable. I think you are.
Yeah, I'm actually running in Canary today, but yeah, Chrome stable I believe has
all of these
all of the same things. And one of the things we say on the repo is that if you're planning to use this code or something like it, you'd obviously need to transpile it or do something with it. But our goal here is partly to sort of show some of these new things, and it's partly to choose the kind of correct thing that we think for the job that we're doing, in which case this is actually a really good use for web animations, and it's a really good use for custom elements, so we're kind of taking advantage of both of those. But in a production setting, as Sammy said right at the start, you probably have to do some dancing to make sure it's doing the right thing for you. Right, all good. We're actually doing really well, but what we need to do is at the end, so the thing is, at the moment, when we click it the second time, it goes back to the first side. So for temporary, and we'll come back to this, I'm just going to set the side so if the side is currently scflipcard.sides.front, if it's the front of the card that we've seen, then the side is now going to be that.sides.back. Otherwise, it's going to be front again. So
I love these kind of expressions. They always feel so redundant.
So yeah. So now we can basically, you can see how we're actually card flipping.
And we already have a pretty thing going on there.
This is really good fun. It's so much fun to keep tapping that.
I want to do it. It actually works.
It does work.
Amazing.
Now here's something that if you've not seen Rob Dodson's Alley Casts yet, it's a brilliant show, very new on the channel, and one of the things he talked about in I think the first proper episode was the inert property, which basically at the moment these two buttons for flipping the card, both sides of the card, you can only see one at once, right? And so you want to be able to kind of say to whichever one's the back side of the card, you shouldn't be tabbable right now.
You
Usable.
could tap to both the front side button and the back, and you wouldn't even know where the tap focus is when it's on the back side. But when you press enter, the button would still get clicked.
So if I do document.activeElement, so this is not going to help.
You can
parent.
Active element parent.
Parent. Yeah, do that. So for example, here I had it as it was the front, but if I tab again, it's the back.
So it has focus. We can't see it, but if somebody pressed enter or had a screen reader, he would hear things that are not even there. We didn't intend them to use.
Exactly. We want to handle that. So inert is a thing. There's a polyfill. I've gone ahead and actually added it into this folder. So we're just going to pop this in like so. And what we'll do is in the card flipping code here, when we are...
People are being snarky about you using an enum and not just a boolean for which side is in the front.
Yeah, okay, fair enough. I mean,
technically this is the more extensible approach when you want to have a flippable cube at some point or something.
Yeah,
who knows?
Who knows?
Definitely a valid point. We could have used a boolean and have all of this logic be a little bit simpler. But in this case, I guess it's more explicit and more extensible.
Yeah, you could, and I actually like the readability of saying this is the front side, it's the back side. But you're right. If it was a boolean, then we could say this side is not this side, which would flip that immediately, and that would also be perfectly a reasonable thing to do. So I'm going to start by saying this .back.inert, because I've added in the inert polyfill. It's true. And the front...
also, just to slap ourselves on the back, the thing that Rob Dodson fixed with his inert polyfill in that Alleycast video was our side nav, one of our very first live streams.
Not really slapping ourselves on the back so much as actually having our work corrected.
I tried to frame it nicely here. Let's just make us sound good. But yeah, he fixed our side nav, which was, in terms of accessibility, not good.
So we're going to say the front is not inert, the back is inert for now, and then obviously at this point we can pretty much swap those over. So the front is now inert and the back is not, and here the front is inert and the back is, the front is not inert and the back is. So again, you probably could tidy this code up, and it is very repetitive. So there would be ways to resolve this, I'm sure. But it does mean that we have that, blah blah blah. For example, do that, and then if I go back in and tab again, you see we don't go through to the back element. So it's basically toggling the availability of those elements very easily for us. It's a brilliant little thing. Is the inert property. I would love to see this become part of the platform personally, because I think it just makes these things so much more obvious. The other thing we probably want to do as well is we'd want to say this .back.focus. We want to actually make sure that we focused the correct part of the card, because
I think you switched those the wrong way around.
No, if you're on the back.
Oh, it's after.
So we're bringing you back to the. But in order for that to work, we actually have to set a tab index to -1. So it's not naturally tabbable, but it needs a tab index in order for focus to work.
If you didn't understand it, watch Rob Dodson's episode.
Yeah, and also there's a Udacity course as well, so that's well worth taking as well. So we're doing really well. All I want to do now, is I want to add some shadows, and that's going to be fun. And I can't decide. Do they want us to do the bit that doesn't perform well first, or would they like us to jump to the bit that performs well? That's a question for the live stream.
I'm going to make a call for them here, and we want to see the laggy version first.
Okay, well, it's going to be hard to do the laggy version without a phone, but I will code it up, and then we'll talk about why this will lag on a phone. Okay, so I'll do that. So what we need is 2 shadows.
Speaking of, I think in Canary we now have landed CPU throttling.
Okay, that might do enough. We'll do a timer. In fact, actually, before we even get into that, let me show you this. Paint flashing. So this will every time we repaint the page, you see this paint flashing. Okay.
Remember this button; it's very helpful.
So what I want to do is just come off this here. If you see this there, we see some paint flashing here. Okay, because of the button. Okay, but other than that, the cards itself, they're not actually.
There's an initial paint, and then the entire animation finishes without a repaint, which is good, which is what we want.
And the other thing is, if we did document. Actually, I can do it this way. If I just grab the card and I say $0.flip. There we go. You see, there's that right at the start there where we get a bit of an animation. So what we can do is, since we know we're going to be animating that. Let's put will change transform.
So what happened there is that the card that the browser didn't know that we were going to animate this because we didn't tell it, so it rasterized it onto the background. But once the animation starts, it gets its own layer, so it has to repaint once.
Well, interestingly, I am still seeing this where it is still painting. So there's a bit of a mystery there for me.
Huh.
I have a wonder. Just let me just set the buttons to display none. See if that helps. They're still doing it. Interesting. It's because of the inert stuff, I think. Let's just try switching out inert for a second, seeing whether that's doing anything for us. There we are. Okay.
Interesting.
Yeah. So there's something to be aware of there. But now that we've actually, I'll put the inert stuff back on because I still think it's worth having, and I still think we'll get away with it. I don't think it'll be a performance issue in reality. But I just wanted to show this, that right now this card animation is not painting. Okay.
So with will change, we told the browser keep this on its own layer at all times. We can start animating immediately without having to wait for the browser to put it on its own layer and then do transforms.
So what I'm going to do, I'm also going to do a timeline recording over here. Let me just switch off the paint flashing. Not that it's actually going to paint flash, but I'm going to switch it off anyway. And I'm going to flip the card again, just so that you can see what the timeline looks like. So this is the back face visibility bit here. This is a well-known optimization, I suppose, that Chrome does. When something stops being back face visibility hidden, as in the moment it's got its back to us, it doesn't actually get painted. It's when it comes round at 180 degrees, Chrome says, this is now is a good time to paint this. So that's why we see that slight hitch in the middle. But it's fast enough that we still actually get away with it. We don't really notice it on the way through, but it's worth noticing that it's actually happening there. Main thread, it couldn't be any quieter on the main thread if it tried to be.
Really good.
There's just nothing going on there.
At a comfortable 60 FPS.
Well, we're at 50 FPS here because of the screen capturing, so you'll notice that we're getting roughly 20 frames a second. So this 50 frames a second is by design to be super clear. We're capturing today at 15 frames a second, not the usual 60, and you can see that Chrome's adapted itself.
But as you can see, there's loads of white space in between the frame bars, so we could do a lot more work per frame.
There's nothing doing. So that's really good. So I just wanted to kind of point that out before we get into doing the shadow stuff. Right, so now we need a shadow. Now, I am going to switch back on the inert as well, just because I don't want to lose that. I remember from my school lessons that there's the thing called the umbra, which is the kind of the darker shadow underneath, and there's the kind of softer shadow, which is the penumbra. So we're going to have an umbra, like so, and we're going to have a penumbra, like so. Now,
or as the Germans call it, Schatten und Halbschatten.
There you go, you see. I love it. I mean, you were telling me, what did you think CSS would be called?
If you were to translate CSS to German, I think it would be called kaskadierende Stilisierungsvorlagen, which I think is a brilliant word.
I mean, that's just amazing. I mean, I've got no chance of either remembering it or pronouncing it correctly, but when I hear it, I'm just going to call it CSS. So, good. Right, what we need to do, let's start with the Umbra. Let's SC card Umbra. And we'll do the penumbra as well a little bit here.
Sounds like a cocktail to me.
Does it? Sounds like a shadow to me. Width 100%. Height 100%. Height 100%. And then we'll do background. There we are. It's a black background, and we're going to say position absolute top 0 left 0.
So the first question from you was going to be like, why not just use box shadow?
Right, so yes, that's a fair question. So the box shadow is going to give us a problem that we will want to animate this shadow, because the further it gets away from the background, the more we want to have a blurry kind of shadow. The problem with that is that you have to do that box shadow, have to create that box shadow on every frame. And as we've just shown, we're currently not painting on every frame. All we're doing is we're taking textures and we're moving them around, and we don't want to repaint those textures. Changing box shadow will change those textures.
So we will repaint on every frame, and we would most likely be very much below our 60 or 50 FPS.
Exactly. So we don't want to do that. So, okay. So I'm wondering why my button has stopped working, because I did have buttons that worked before. So
no, you made them display none and used the console.
Except that in the display none. There we are. Okay, they work. Right, so we've got these two black background divs behind. I'm going to set the penumbra to display none for now. We're going to just work with the umbra for a second. Display Display none. Okay. Okay, so we've got this black background that's sitting underneath, which doesn't look particularly good. Okay.
I would ship it.
Yes.
And that's why I don't design.
Yes. Right. What we need to do is we need to do so box shadow. No, we're not going to do that because that will cause a repaint. What we might want to do is we might think, you know what I could do? I could do a box shadow here and this would be fine. Or what I'll actually do, because I'm thinking really would be nice, is we'll do a WebKit blur. Well, it's WebKit filter, isn't it?
Yeah.
Filter, and then blur, and then 2 pixels.
So these are all the CSS filters that CSS lets you apply to elements. So you can blur out things, you can invert things. I don't even know what the other SVG filters are that you can.
There's the sepia one. There's like yeah.
There's a website out there that recreated all the Instagram filters just with this attribute, which I thought was a really interesting thing.
I've blurred it and I've transformed it down 2 pixels. Okay, so it's kind of it looks like a kind of a box shadow kind of feeling thing there, but it's not really very nice because it's also a bit too dark. So we'll bring the opacity down to say 0.3. Okay, so it gives us, now you can see it. It's just there. I mean, maybe you have to kind of look at it. Then you see it when I do the animation. It's there. It's you know
below the element.
Below the element. What we'll do inside our code here. So we've actually we haven't got the Umbra and the penumbra picked out yet. So we're going to do that now. Let's do that. Umbra is the Umbra. And the penumbra is like so. Ta-da! Yeah,
the question that we have is, will containment help with the painting lag? And I guess in this case it won't, because we are not actually fighting against the bubbling of...
Right, we're not. And we're actually, what we're fighting against is what's known as it's a convolution filter that we've got here. Blurs require not looking, when you're figuring out what the pixel should be, you have to look at that one that you have to look at and you have to inspect. And so it makes it proportional to the amount of blur that you've got. So if you've got a blur of like 20 pixels, that kernel around the pixel, that one pixel that you're trying to do is quite large, and it depends
basically
on the algorithm.
Averaging out the environment
and
around
the distribution, which is the Gaussian distribution, that's the name Gaussian blur. But you're doing that per frame, per pixel of the shadow, depending on how blurry you've decided to make it. So this is a point at which, even if you could contain everything else, the sheer computational cost of doing that paint work, that blurring work, that we just get to type one line of code, which is WebKit filter blur 2 pixels or 12 pixels or 20 pixels, but under the hood, all the browsers are having to do all this maths to try and get to the actual blurriness. And that stuff we kind of want to bake. We don't want to be doing that on every single frame. Anyway, right, so I wanted to, with the shadow here, I'm going to say animate, and I'm going to do Umbra, and then do timing. And
so basically giving the same animation to the...
Well, it will be penumbra.
Oh yeah.
I have to define what Umbra and penumbra are, and I'm just going to get rid of that for a second. So, const, the Umbra.
Or a very similar animation.
Yeah, it's going to be very similar. Here, what we're actually going to do, we're going to set, for the Umbra and the penumbra, we're actually going to set backface visibility to visible. We want to make sure that when the shadow flips over, it's still actually there, because it's a shadow and we can do that kind of stuff. So here, what we're going to do is we're actually just going to go with a transform again. And what we want to do is we want to rotate. We want basically to rotate 0 degrees. I'm not even going to push it back or forwards, I don't think.
Because it's on the ground.
It's on the ground. It's basically, yeah. So we're going to do that, but what we're going to do is we're going to translate it down. So we're going to start with a translate Y of 2 pixels. So it's just a little bit below the card, so it just feels like it's just a little bit there. Rotated at 0 degrees, and then what we're going to do is we're going to that. And we'll bring it down, say 62 pixels, and then back to 2. So it's going to come sliding down and then sliding back up. And we're at the halfway point, we're going to do it to 180 degrees, get rid of that. And we need our 2 offsets as well, because we want it to kind of copy the behavior of the main card.
Yeah, it wouldn't be in sync. It would be weird without the offsets.
Correct. So hopefully we're going to see something that slides down, rotates, and slides back up again. And that should, in theory, work for us. Okay, let's try that. See what happens.
Before we click. For the people who've joined us, welcome. You're now seeing the the first stage of what we're trying to build, which is a 3D flipping card. Click it.
Okay.
Let's hoping it works.
No, it didn't work.
It does work, but it's just flipping the wrong way.
It is.
Which is actually pretty good. I
yeah,
like
it is
that.
cool. It's because I didn't put in the actual axis. I just said rotate. So it assumed I meant on the z-axis, actually. So we'll do that. There we are. Let's try that again. There you go. Okay, now we're talking. We're actually getting a nice little thing going on there. Okay?
And when we enable repaint flashing...
Yeah, okay. When we enable repaint flashing, it's going to lie to us. Okay, now we've got. I'll tell you what. I need to.
So you would think this looks good.
I'm gonna switch off the inert again, just so that we get to see that, and we will get some from the box. Yeah. So let me just switch off the boxes again, just so that we can see this, and then we can talk about why this isn't actually as good as it appears. Okay. Oh, I've got to actually select that element first. SC card, console. Okay. So this is pretty much what we saw before. There we are. No.
So now we have a flipping card with a shadow, which
is great.
Good,
this
right?
is fine, but we can make it even better. And I think what we'll do is just temporarily we'll do our penumbra now. So I will do the penumbra stuff, which is going to require getting rid of this particular code, and we will do this. Bring this across, and we're going to start it off at 0, and we're going to blur it up to 12 pixels. Okay, and over here the penumbra. We'll take this little chunk here, call this penumbra, and what we're going to do is we're going to do exactly the same animation. Now what we can also do is we're starting at an opacity of 0.3 here, but we're going to animate this down to 0. I'm only doing 0.0 so that the indentation stays the same, or the distance, because I find that easier to read. I'm going to fade that out, the umbra out, but we're going to fade in the penumbra, which is, so it's not technically correct, but it kind of should work for us. And I'm going to go from 0.
As we said, if it looks right.
It is right. Okay, so this is the penumbra.
So what we're trying to emulate here is that when you have light source and something going towards the light source, the diffusion of the shadow is going to get bigger.
It should feel blurrier. And what we're trying to do is we're just fading between something with a 2 pixel blur and a 12 pixel blur. And I've slowed the animation right down now, so hopefully, let me just switch off the paint flashing a sec. See if it's actually visually correct first, or at least kind of visually correct. Yeah, I've got to do all my button unhiding stuff. That's my fault, isn't it? I keep forgetting that I'm doing that. Okay, so you see how we get that crossfade between the two blurs?
Look at the edges of the shadow. It becomes more blurry the further the card lifts up. And that's exactly the effect that we're looking for.
Let's slow it down even more, just so that it's really obvious. So we're getting that across to that blurrier version, and then back into the sharper version as we go back down. The eye will notice that. Even when the animation is fast, the human eye will notice it. Hopefully as well with the paint flashing, we're going to see... come on, Paul, you can do it. You have to actually select... There we are. Okay, with the paint flashing, we're in a pretty good spot. Okay, we're doing pretty well here. Now, this is the bit where having done all that work, I'm about to tell you that this is not actually very good. Let me show you why that is. Well, I'm not going to be that easy to show you why that is, other than I'm going to have to, let's see if we can at least figure something out. The CPU throttling there. Okay, so let's try and see what we get. So rendering.
Let's try this.
Let's see what happens. Okay, so we're going to do our animation like so. Now, we're on a fast desktop machine. Hopefully, down here somewhere, you can see the amount of time on the GPU is actually occasionally quite hefty.
That is a good amount of time for a machine this powerful.
Yes, and the reason it's taking this long sometimes, and this is going to be worse on something that doesn't have a meaty GPU like a phone, the WebKit filters are done later on in the pipeline. So we talked earlier about the fact that we're kind of baking these textures, and these textures actually get sent over to the GPU, and then they get basically put into boxes and moved around the screen. And that's what the transform's doing, it's just moving those boxes around. When you apply a WebKit filter, we take those textures at the end of the pipeline and we do something like a blur to them. So that blur is actually happening GPU side, but it means that we can't do any other instructions to the GPU like keep this animation going, because it's going, well, I'm busy doing that blur that you just asked me to do. So we need to find another way to basically do this blurring. As I say, if you have to trust me. If I do maybe even a low-end device, just see if it'll do it.
As I'm presuming this is not really CPU bound, so we might not.
We might not see it here. Yeah, I mean,
it still looks good.
Yeah, it still looks okay. It's something. As soon as I did it on and checked it on my phone, this effect, I was like, yeah, this isn't good. So okay, let's jump to what we can actually do instead. What we can actually do instead is we want to bake something with a texture. Now we could go 1998 style, as you referred to it the other day, and we could make pings. We could actually make a graphic of a blurred box.
Basically, pre-compute the blur, put it in an image format that has capabilities for transparency because we need them for the edges, and we could use that. But we also live in the time of responsiveness.
Yeah, and
different screen sizes.
So how are we going to do that? Well, I mean, there are options. You could use, say, border image and so on.
True.
That is going to work for you. What we've chosen to do today is actually to use SVG, because SVG supports Gaussian blur. And if we were to set those Umbra and Penumbra divs to use these SVG files as their background, those will get kind of baked as a texture, and then we will get exactly the same effect. We won't have the blur in the CSS.
So we're using the same process. We are blurring a black square.
Right.
But we're using it at different points in the pipeline.
Exactly. So let me just show you what one of these actually looks like. So
before we start, you have an interesting question, I thought. How is the flipping element affecting its surrounding elements?
It won't.
That is the beauty of transforms.
Transforms don't change the actual layout position, if you see what I mean. They're not moving. They just are. They look like they are, if that makes sense.
So we lay out, or each browser layouts, all the browsers lay out their elements, and then the transforms get applied purely on a post-effect basis.
Yeah.
So if you say scale, it will get the image that has been rendered already will get scaled.
Yeah, and then it might get repainted at the end. This is a key.
True. Sorry. Yeah.
It is a key pointer though. Sometimes if you do a scale at the end of the scale, the browser will go, well, now I need to kind of make that image bigger, for example, so it doesn't look blurry. So there is some smartness here, but in this particular situation, we should be fine. So our Umbra and our Penumbra, you can see what that looks like. I'm going to open that in Reveal and Finder, and then I was going to drag that all the way down here into Canary. So this is what it looks like. This is pretty much the same thing we actually got from the CSS blur filter. So let's see how we get on with that. What we're going to do though is we're going to switch across. So we need to go back to our CSS, and we are going to get rid of the background there. We don't want that. We don't want the blurs. We definitely don't want those. But everything else can actually stay the same for now-ish. What we're going to do is we're going to say background URL, and we're going to say images, and this one is the umbra.svg. Downside, center, no repeat. Okay, and I'm going to say the same for the Penumbra.
Shouldn't it also be a contain?
Well, I mean, this is the thing at the moment. They're set to 100% width and height. They don't want to actually be set to 100% width and height. Again, I've hard-coded these values. Yeah. You can do this in a responsive manner, but we'll just do it like the hard-coded version today, just to, get us through. So the actual width of the Umbra in the SVG is 270 by 390. So what we'll do is we'll go back and we'll set this to width 270 pixels. Height, did I say 390? I think I did. 390.
Question on the side, which is probably interesting to you. We call it a card flip, but shouldn't we be using flip?
We don't need to. So flip is a really good technique when you don't know the transforms ahead of time.
Exactly.
We've been able to hard code these transforms because we know the card is going from one side and it's rotating 180 degrees.
So we know from 0 degrees to 180. If it changes size and we don't know the size of the screen or anything like that would get involved, that's the second flip comes in.
Yeah, when you don't know the transforms ahead of time, you would use a technique like flip. We know those ahead of time, so we shouldn't try and make it more complicated than it needs to be. So that's 270 by 390. Now the problem there is that the card itself is 260 by 380, which means we have to position this top and left by 5 pixels, minus 5 pixels, top minus 5 pixels, left minus 5 pixels. And that will now position that correctly. Same is going to hold true for the Penumbra, except that it's going to be even bigger. It's 330 by 450. Do we need
a position relative or something?
No, we are position absolute. So 330 by 450. And so it was, 260. So that is 70, which is 35 pixels. So we minus 35 pixels, I think, in both directions, all being well. Cool.
Well, I trust you.
All right.
I say that.
So all being well now, if that works, there we go. We actually have, it doesn't look visually any different, but the umbra is backed by this SVG, and the penumbra is backed by this SVG over here. And I'm going to switch back on my inert as well so that I don't forget to do that. And basically, just record. Tell you what, I will. Yeah, I'll do it. I'll do it at slow speed just so that there are plenty of frames to go at. There you go. Still completely quiet, totally quiet. Nothing doing. Dead fast, dead.
But now it will also work on a device that doesn't have a beefy GPU.
Exactly. This will work everywhere. The only other last couple of bits and pieces that I'd like to do for a little bit of tidiness' sake is we flip the side immediately, but we really probably only want to do that at the end of the animation. So what we can do here is we can do an on finish. So this returns something. I believe in the future this will start to return a promise, but for today
they are reworking the API, aren't they?
Yeah, on finish equals, and then it's a function, and we could bounce this out to its own on finish, but I don't think we need to. And the other thing I think I'd probably want to do, this dot locked. I think I want to lock it while we're in the middle of the flipping over animation. So this locked is false, and it's when it's there, when it's finishing, it's also unlocked. And then at the start of the flipping animation.
So this would basically prevent users that are just violently clicking
to
trigger multiple animations at the same time.
You could figure out ways, I'm sure. If it's locked, we're just going to return early so that we don't do that. So you can't basically, cause this to go lots and lots of times. Let me just speed it up. Actually, no, let me just check it actually works. So that with a 0, go to the console. So we select the card, and we can say flip. And if I see now, you see that's still broken. So all being well, it's now ignoring me until it reaches the other side. And at the end of the animation, it should unlock so that we can now call flip again, and it will go back over. So we're actually sort of protecting ourselves from that kind of brokenness that we just saw there.
Something I always forget in the first iteration of my code, and then I wonder why people start using it
and saying it's broken.
These violently clicking users. Always breaking my stuff.
Okay, so there we are. You see, ta-da! We have a 3D flippable card. Why don't we just because I think we have a few minutes left. Let's do axis equals. I'm going to do random, but let's see what we get here. Because this should work. In fact, let's do this. Let's do it this way. When we'd need to do the attribute updated callback. So after this, I will actually add some of that code back in. But we can say this dot axis equals this dot get attribute attribute axis, or default it to the x-axis, for example. Okay.
So I'm assuming you're going to define how the card flips.
Yeah, and we're going to say if the axis equals, and we'll do it to uppercase, I suppose, to uppercase equals random. We'll just choose one at random. So this dot axis equals math dot random is greater than 0.5. We'll do the y-axis. Otherwise, we'll do the x-axis. Okay. So you might be wondering, what is he doing here? Well, we've chosen at this point to always do rotate y. Well, we can just select all these now. Oh no, I'll tell you what we do. Full rotate y. There we are. La 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 la. There we go, and we'll do this dot axis. And for these ones here where we didn't actually have them set, we're going to have to. Yeah, I was wondering if that was going to happen. Sometimes when you do the
multi-cursor things in VS Code are a little bit iffy, in my experience.
It can be, yeah. So sometimes you get this kind of situation where you have to do a little bit of tidy up.
Yeah.
But all the same, because I set it to random, hopefully.
See?
There you go. We got one that flips an X here, And if I refresh, we got one that flips in Y. It's almost like it decided to help me out there and didn't do like 10 in a row in X. So there you go. That now you see that code just works there for whatever axis we want, and we could change the perspective. We can change we can figure out.
We could give it more attributes, like how far should the card lift up.
Yeah,
all these kind of things.
Stuff.
Custom elements.
Duration.
That give you power.
Yeah, duration. We know we've hard coded the duration to be what it is. We can why not? Let's just do that. Let's just do this. This dot duration. We have the time, I think. Hope everybody's enjoying this. Thank you so much for joining us. It's lovely to have you all here. I'm going to say parse int that. And this instead of axis is going to be duration. No, that one shouldn't be. That should remain as this axis. So we're going to ask for the duration attribute, and that's not got a remix. There we are. If is none, this dot duration equals.
Whenever you're handling user input, and attributes are in this case user input, validated.
Yeah, absolutely.
Golden rule.
So we're going to basically ask for the duration attribute, or we're going to default it to 800, and so we can do this now. Duration equals 3000.
So now we should have a 3-second card flip.
In a random axis.
That felt like 3 seconds.
There you go.
Well done, Paul.
There you go. So thank you so much to everybody who's tuned in live. Obviously, if you're watching this, on demand, as it were, welcome. I hope you've enjoyed this.
If you just joined, you're too late.
Yeah. Nah, next time it's normally UTC +1 at 2 o'clock.
If you didn't know that we're going to be live, subscribe to this YouTube channel. Follow us on Twitter. We announce this ahead of time and a few minutes before we go live. So no excuse next time.
Okay. The code will go up onto GitHub as soon as humanly possible, once I've had a little bit of an additional tidy up. And I guess we will catch you next time.
See ya.